This is page 101 in your math journal. We're going to call this one Geometric Solids. Okay, we're going to be matching a net with the geometric solid. And you should have already pasted this in your math journal. But all a net is a geometric figure, all the sides kind of squished flat. So here we're going to be comparing their nets to their figure and which one makes it up. So down here, net A. Okay, we have two pentagonal sides and 1, 2, 3, 4, 5 rectangular faces. This tells us it's a prism because of the rectangular lateral sides. So down here on net A, we don't have room to write the name, so we're going to just do it down here at the very bottom. So I want you to write net A. So we have A, B, C, D, E, F, G, H, and I. So these are the nets. We're going to write their names. So looking at this, this has 1, 2, 3, 4, 5, 6, 7 faces. Faces are the flat surfaces. So go ahead and fill in a 7 there. Okay, vertices would be how many points this thing would have. So if we're looking at this, each one of these is going to be a point. So there's going to be 5 on this one and 5 on this one. So there are 10 vertices. Okay, each edge would be each line. So there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There'd be 16 edges on that figure. Okay, let's look over here and find a solid that would match that. We need pentagonal sides, and we need to have rectangular lateral faces, so it'd be M. Okay, the name of that one, that's what we're going to write down here because you don't have any space. Pentagonal, or pentagonal, however you want to say it. P-E-N-T-A-G-O-N-A-L. Prism. The base is a pentagon, and it's a prism because it has lateral faces that are all rectangles. Okay, let's look at our next one. Okay, look at your figure because you can't see it as well on mine, but there's a line right there, there, and there. So looking at this, we have all rectangles. There are 6 faces. So down here, let's write 6 faces. Maybe if I zoom out a little bit, that might help. There we go. So there are 6 faces on this. They are all rectangles, which means it's going to have to be a prism of sorts. The base shape, since they're all rectangles, it has to be a rectangular prism. So let's look over here and find which one would match. Okay, see how these are rectangles, not squares? So this would be it. This would be Q. So the solid that matches it is Q. It's a rectangular prism. So let's write the name down here. Rectangular prism. Okay, now vertices, how many points does it have? It would have 1, 2, 3, 4, 5, 6, 7, 8. Well, here, it's easier to look on this actually. 1, 2, 3, 4, 5, 6, 7, and then 8. So this would have 8 vertices, which since it's a 4-sided base, we have 2 bases. That would be where all those sides meet. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There are 12 edges on that. Okay, this one right here, we have 2 circles, so the circles are our base, and this wraps around. So let's look over here and see what would match that. I need 2 circles. Here would be 1, here would be 1. Okay, this is a cylinder. So let's match L. Okay, its name down here is a cylinder. Okay, a cylinder has 2 circle bases. Now how many faces are on this? There are 3 faces. So we have 3 separate shapes there. Vertices. Vertices mean it comes to a point. There are absolutely no vertices on this one because it's round. So let's put 0. Now edges, we have 1, 2. There are 2 edges on this. Alright, let's look up here at D. Notice these are all the same shape. They are all squares. There are 6 sides. Look over here, which one would that match? 1, 2, 3, 4, 5, 6. That would match N. Okay, this net, there are 6 sides, so there are 6 faces on this figure. Vertices, there are 1, 2, 3, 4, 5, 6, 7, 8. So 8 corners. And edges, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 edges on this. Okay, and the name of this one is a cube. It's technically also a rectangular prism, but it's a cube because all sides are squares. Okay, E. I have 1, 2, 3, 4 faces. They're all triangles. So if I were to put this all back together, all these sides need to touch each other. I'm going to be making a triangular pyramid. So the name of this one would be triangular pyramid, because it has a triangle for a base. And it comes to a point. Okay, the solid that matches that is O. Okay, there are 1, 2, 3, 4 faces. If I put all of these together, 1, 2, 3 edges. 1, 2, well, let's look, it's easier to see on here. 1, 2, 3, 4, 5, 6 vertices. Oh, sorry, that was 6 edges. Vertices, there's 1, 2, 3, 4 points, so there's 4 vertices on that. Okay, on F, we have 3 rectangle sides and 2 triangles. So we have triangles for bases here. And since we have 3 rectangular sides, this is going to be a prism. So let's look over here for a triangular prism. Okay, 2 triangle bases, 3 rectangle sides. This would be a triangular prism. Okay, that matched with, let's see, JK. Alright, this has 1, 2, 3, 4, 5, 6 vertices, 6 corners. There are 1, 2, 3, 4, 5 faces. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9 edges on this item. Okay, let's look at G. We have a circular base and a triangular shape here. That means this is coming to a point. That would be a cone. So let's match G with J. This one has two faces. Vertices, we have 1 point on this. Edges, there'd be 1 edge on this as well, just that around the circle here. Okay, and down here let's write cone. Okay, we're almost done. H. We have a square with 4 triangles. So if I were to put that together so that all the sides were touching something, I'm going to end up with this. This is a square pyramid. So this matches with P. Down here, let's write square pyramid because it has a square for a base. If we look here, we have 1, 2, 3, 4, 5 faces. How many vertices do we have on this? We have 1, 2, 3, 4, because remember that's a square. 5, so there's 5 points. And edges, we have 1, 2, 3, 4 on the back, and then 4 around the base. That would be a total of 8. Okay, last one. We have hexagons and a bunch of rectangle sides. That's going to leave us with R. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8 surfaces on this one. There are 6 points along this side and 6 along this side, so there are 12 total vertices. Edges, we have 6 on each one, so that would be 12 plus the 6 around the outside, so that'd be a total of 18. Almost done. Let's down here we're going to write hexagonal. So hexagonal prism. Okay, that just gets you familiar with what a net is and how to match it with the solid it goes with and some of their names.